Alright, guys. The time has come. The time we have all been waiting for so long. Printer repair. You heard right. This is not your imagination talking. This is real. This is not a drill. The first step in my troubleshooting guide I created for myself is to remove the right door. And here you can see from the repair manual, removing the right door. Remove 2 screws, call it one from the lower edge of the cover. So these 2. So let's do it. Okay, we gotta move some stuff out of the way. They're Phillips. Get out my Phillips. Let me get a flashlight on my head. Oh, okay. 1 screw down. Okay. And the second screw is done. Now what? Open the scanning assembly. Grasp the cover by the handle and by the top. And then pull the bottom of the cover. And then up gently, rotating the cover away from the device as you lift it. Oh, that was extremely easy. Huh. Did not expect that to just come flying off. Usually, things are really hard to take off. Okay. Ah, beautiful. Guys, we just removed cover, boys. We just friggin' did it. How do you like them apples, huh? How do you like them apples? That is some real progress, my friends. That's absolute real progress. Quiet, mailbox. Way better than Vince the Idiot. Oop. Okay. So, let me just rotate this a little bit more. I get to reward myself for getting something done. I'm gonna sit back and relax and just stare at this thing for a little while. Relish in my victory. What is the percentage of me fixing it? I don't know. I can't say because I don't know. I haven't pinpointed specifically the problem yet. So it's too early to really know. I'm going through a step-by-step troubleshooting guide. One step might take 50 hours, or it could take me 2 minutes. It depends on what it ends up being that's wrong. Look up how to take off right gear assembly and do it. Okay. Let's try to find that. Wake up. What do you mean I have to get in deeper? Stop listening. You're telling me even if I fix this, I'm still not having proven myself? Or I still haven't proven anything? Remove the right support assembly. Oh gosh. Wake up. Page 204 hyphen. Removing the gear assembly. Press Alt Tab. Oh, shoot. What the frick? There's no way I'm taking apart all that stuff. Oh my gosh. 186. Hyphen. Removing the right support assembly. Remove 2 screws. Stop listening. Remove 2 screws, call out 1 from the cover. It's right above this thing. Okay, I found it. Oh, I see the other one. It's right here, guys. If you're wondering. You're wrong, Ice Cosine. This printer's very worth fixing to me. Do you realize the amount of engineering this thing contains? The attention to detail, the precision, it's just incredible. This is an excellent printer, and just having it open and looking at it is just unbelievable. I can learn so much, and I can see this through different eyes than everyone else. Everyone else just sees blah, but I know what this stuff is. I've been studying this. Okay, that second screw was smaller, by the way. Press the scanner release button, grasp the lower part, and lift up. Ooh! Did you guys catch that? Look at that. Just popped right out. Okay! Do it bigger, grow a wig. Wake up. 186. Press return. Stop listening. This is the only printer I own, and this is the only printer I have to repair. This repair is going to help a lot of people, because I'm making a YouTube video about it. It's also going to help Mailbox, because Mailbox is going to see how skilled I am at repairs. It's going to restore his faith in me as the world's greatest roboticist. Okay, I disengaged the latch. Took some fiddling, but you just got to get it right in here and start twisting to clockwise, and it popped out. You can see that it now lifts kind of freely. It's now loose. No, by being able to repair a printer, you're demonstrating the ability to understand a complex device and work with it, work on it, and make repairs to it. And that demonstrates the same thing you'll need in order to make repairs to and fix and understand a robot. Oh, I'll do it. Better believe I'll do it. Okay, so this is done. From the back of the device, lift and disengage the latch at the top of the cover. I don't know what they're talking about. Okay, we gotta turn the device again. Okay. Maybe this camera angle is better for you guys for this part. Okay, they got the screwdriver right. Let's see, at the far outermost, it's there's a bridge here. He's between this bridge and this thing. Something real like that. Nope. I'm not seeing it, man. Oh! You know what? It was better to do it right here. I came in from this angle, and I lifted this little latch right here. I just popped this up. Boom. You can see, and now that disengaged the whole cover, and now I can just come back and just work it off. I can't work left or right-handed while I hold the camera with my left because my bad arm, my shoulder injury. You guys go look from this angle again, I guess. So this thing can now wiggle off, I believe. Boom! Heck to the yeah! That's another one down. So that was moving the right rear cover. Wake up. 186. Press return. Stop listening. Each one down I should... Well, I'm rewarding myself now with getting to rest my back and my body. I'm gonna lounge for a while, take a little nap. Eh! Alright, you can see I just did that. Drop that open. Stop listening. Disengage the latch. Call out 1 at the top of the input-output cover. Okay, that's there. Yeah! Come get some! Mailbox. Never doubt the ultimate, the one and only Larry Art by Robot again. Ooh, forgot. Now I get to reward myself. No. Oh. Wake up. Press return. Press return. Paste it. Press return. Press return. Press return. Page 173. Press space. Press space. Press space. Press space. Press space. Easy. I did not expect to have to take off this cover, but whatever. I guess that means I'll get to see more of the printer. Ugh. I'm shocked by this. Remove the screw from the lower edge of the cover. Alright, it's just below that panel. Okay. Well, come on. Got him. Magnet screwdriver for the win. Okay. Now I have to remove all the tape off the side of the cover because the cover's coming off. So that's an extra step for me. It's not on the instructions. Holy cow, this thing. Just getting one thing done. I want to take off the gear assembly. Required 18 steps. Or 25 steps. Each taking 6 minutes. That is insane. That's like 2 hours just to get to the point where we can actually take off the part that I wanted to take off earlier. That's like if you had to do a brake job and it said like, or like you had to change your alternator on your car and you had to like remove the engine, remove all the wheels, remove the doors, remove the bumper. It's like, goodness, can't I just take the alternator off? It's an accessibility issue. Whoop. Go back. Okay. Actually, I'm taking a break. I think I earned one. That was like definitely a step, even though I didn't get to cross off a step. It felt like I did a step. Okay. Um. Hey. Okay. Uh. Got him! Thought I was gonna break something. That was hard. Alright. Pull the bottom of the cover slightly up and out to release the bottom latches. Got him! Whew! Get wrecked, mailbox. Alright, I'm just gonna clean this thing off a little bit. Mm-hmm. Mm-hmm. Oh, yeah! Alright. Stop listening. Shoot. Got him! can't see what I'm doing here. There. Another one bites the dust. Ugh. Okay. Alright, so right there and right there. Boom, and there's a little owl foot, and then... Okay. Let's do it. Ha! Come get some. Alright. Now we're getting somewhere. Look at that. It's off. That bad boy is off. Okay. Close window. Stop listening. Remove the top cover screws is next. So let's get to that. Good. Beautiful. I guess they left out a step. Removing the left cover. That's what I'm doing now. Aha! So this little thing, I must have skipped that step. Okay. There was a screw I had to take out for that. Now we can get at this screw. Okay. And then... Oh. That is right here. It says press the latch at the center of the gear and pull it away from the device. Yeah, boy. Alright, I had to pinch it to my left and then just slide it toward the camera. Okay. Lift the top cover assembly off the device. Okay. Holy cow. I can hardly believe it. Alright guys, it wants me to remove a whole bunch more stuff and I'm refusing. I'm not going to remove anything else. Freaking done removing stuff. Close window. Stop listening. We've removed enough, man. I'm going after that gear assembly. I don't care if I have to cut something. I'm not removing. They want me to remove the entire scanner, the top bezel strips, stuff that has nothing to do with this. That's ridiculous. I'm not going to do it. I've removed enough. This is ridiculous. There's not a panel on this thing anymore. I'm not going to start removing the scanner stuff. Hell no. That has nothing to do with the dang gear assembly, which is on the right front face of the machine, for crying out loud. This is ridiculous. It's like telling somebody to remove the trunk of the vehicle, the trunk lid, to replace the darn alternator. I refuse, man. enough is enough, man. Enough is enough. I gotta pass this thing around, I think. I can't. Gosh. Alright, I'm officially off using the instruction manual. I'm just YOLOing it from here forward. I don't think it'll be the end of the world. Hope not. I'm just taking off all visible screws on this cover plate that covers the big circuit board behind this thing. Uh... Tweezers thing. Wake up. How to remove a small E-clip. Press space. YouTube. Press return. Alright. Got it. We just turned it counterclockwise until it popped off. You can see it's just about off here. I'm just holding it on so it doesn't fall. And there it is. E-clip removed. Stop listening. Okay. I'm gonna put this back. Okay. So this is the clutch. Stop listening. Which goes to multi-purpose tray pickup solenoid SL92. J112 is right here. It's this yellow pair of pins off the bottom left corner. So I want to trace the yellow lines. Are there any other yellows? No. So that pair of yellows keeps going all the way. Oh! Ends right here. What the heck? I didn't expect that. Well, that didn't really help us. We do need to remove this gear assembly to see what the heck's going on. Close window. Stop listening. Right now we're doing this stuff. Alright. Oh, we don't want to remove this. Alright, I'm undoing some screws from the frame that are connecting to the gear assembly. The upper frame, upper right frame. Anything that looks like it'll be in the way of getting the gear assembly out. Gotta make sure this is being captured on camera. It is, okay. We're just working on this corner section of metal. We just gotta get rid of it somehow, because it's gonna block the gear assembly from getting out. Okay, so this piece came off. That's good, I suppose. And this pair of screws should also help. Alright, I'm happy with that. It's loose, so I can now get the gear assembly out from behind it. It has some tape, black tape glued to it that I don't want to wreck. That doesn't seem to be an issue though. Okay. That was screw 3. Seems like this one would interfere with removing the gear assembly, so I'll take that one out. Alright, here's another one, bottom here. Whew. Okay. Another one here. I'm about to use a little dental mirror to see something I can't see. Yeah. No such luck. Okay. Alright, I'm just going to cut away a little bit of plastic here to give me better viewing access. I don't think this plastic's anything that important. Oh my gosh. What the hell? Okay. Now that we removed this little section, I can look in here better. Oh my gosh, I can see everything now! Holy crap! Check it out, guys! I can totally understand how this is working. Okay. So I want you to look... Hold on. I gotta be able to see the monitor so I can see what I'm pointing at. Okay. So, you can see I'm trying to turn the pickup roller, but it won't turn right. So I came in here. You can see this black gear turning. Right. Hold on, let me move these. Well, let me point to it. Alright. I'm touching it now. This is so critical. I want to make sure you guys can see really well what we discovered. Okay. Alright, so I'm touching the gear here. You can, shoot, I don't even need to touch it. You can see what's happening. Okay. You see the gear tries to turn, but it can't. And you can see a little shelf of black, a step coming off the gear circular part. Right above this stick. Yeah, right there, you can see it. Here's my pointer. You can see it right there. See that little edge? That little edge is hitting this thing. This metal thing right here. I'm hitting it. So that metal thing stops the gear from turning. See that? And that's part of the solenoid. Remember that yellow connector from the bottom left of the circuit board? That connects to here, and that causes this solenoid to move that little metal thing out of the way of the gear so the gear can turn. So it can keep turning. It wants to turn toward us, but that little hook is stopping it. And that hook is a good thing. We want to know how to make the hook pull away from there. Where are we? Okay. Wasn't hard to pull. Alright, so I need my hands back. All we need is something to pull that out at the right moment, because it's obviously not being pulled out at the right moment right now. That tells us the solenoid might be bad. But shoot, I tell you what, man. We're in business. I can see what I needed to see. Okay. I'm going to bring you guys down. And you can watch from there. You're looking down into here. Okay. So what I'm going to do is I'm going to manually pull this thing out. I did a full rotation. Alright, It's kind of funny, but I realized like 99% of the stuff I removed today I didn't have to remove to access and see what I'm seeing right now. I mean, it's okay. It wasn't that much stuff, but well, it kind of was. But it's all good. We got there, man. This is the dream. Okay. Press Ctrl X. Press Tab. Paste it. Press Delete. Press Delete. Press Ctrl S. Press Return. Connect the 24 volts to connector J112. which is the one with the two yellow wires coming off of it, on the bottom left-hand side of the main brain's PCB. DC controller. Press home. Press return. Press space. Press space. Press return. Press delete. Press space. Press backspace. Press semicolon. This will activate the inductor of the solenoid, causing it to actuate and pull the little lever. And that lever should move if everything is working. Press home. Press return. Press return. Press return. Backspace. If that little lever does not move when we actuate it, comma, test the wires yellow with a multimeter continuity test to see if there is a break in the line. Press return. Press space. Press space. Press home. Press Ctrl S. Press space. Press space. Press space. Press space. If the solenoid is not working, comma, and mount it just below the existing one, not even having to remove the old one, and have it just pull a little plunger, which pulls a little string, which pulls that little latch stopper mechanism toward the front of the printer, which will free up the pickup roller to turn toward the front of the printer a full rotation and snatch up a paper. Press home. If press space. Press delete. Press T. Press return. Press space. Press space. Press return. Press return. Press return. Press return. Press Ctrl S. Press hyphen. Press space. We would connect this supply this. To its connector, which is J113 and is located just to the right of J112. Press space. Press hyphen. Press space. The solenoid connector with the yellow wires on the bottom left of the main brains DC controller PCB. Press space. Press hyphen. Press space. And this magnetic clutch has two little green wires leading to it. And we will apply 24 volts across these, completing the circuit and activating the magnet within the clutch, which will cause the turning of the clutch gears to also cause the turning of its central shaft, which by default is decoupled from the turning of the gears. But when the magnet is activated, comma, its center shaft and its gears turn as one due to the magnetic coupling. Press semicolon. If they do not turn as one, comma, we know the magnetic clutch is bad. Press home. Comma. Run a continuity test with the multimeter to ensure the wiring is intact. Press semicolon. If it is not intact, comma, we need to locate the break. Press semicolon. If it is intact, perhaps the inductor coil forming the magnetic power has melted its lacquer insulation, causing a short and reducing the magnetism involved, so much so that it doesn't magnetically couple with enough force to turn the gears to turn the pickup roller. Press semicolon. If this is the case, comma, take apart the clutch by cutting away the housing removing its E-clip and sliding away the housing, and inspect the inductor coil within. And apply fresh, high heat lacquer to the magnet wires to get rid of the short circuiting, and run a test to ensure that this fix worked and the clutch is working again. Press colon. We have indeed found that all of the gearing systems work, and we were able to test turning the shaft that the magnetic clutch was connected to at the bottom center of the gear assembly, and that turned the gears that turn the pickup roller. And we were able to make the pickup roller just by manually removing the lever acting as a stopper, which is typically activated by the solenoid. And turning the shaft that the magnetic clutch attaches to. Semicolon. So we know it has to be either the magnetic clutch or the solenoid that is not functioning properly, period. It is not a fault of any of the gears, because my fingers, acting as the magnetic clutch and as the solenoid, were able to do the job that this pair of devices normally would do, period. Both of these devices require 2 wires that form a 24-volt inductor that creates magnetism. In the case of the solenoid, semicolon, that magnetism causes the lever to lift off the pickup roller shaft, freeing it to turn. Press semicolon. In the case of the magnetic clutch, comma, that magnetism causes its gears and its center shaft to turn as one and become coupled. Whereas when that magnetism is shut off, they are decoupled and turn independently. Press semicolon. Starting out, I put all the screws in order of when I took them off. Starting at the back near my whiteout, I took off that big screw, then to the left of that, that small one, and then I took off those three, and then these two, and then those two. Or that one, that's one in the middle, and then these two right here. So I order them back to front, and I tape them in place so they don't roll around and I lose that ordering. I think the ordering is important. These 4 screws right here are the ones that held down this thing. This is a PCB board that runs, I believe, the scanner system. This PCB board, which is behind it, because this one with the cage over it bolts over the top of this one. That cage stops electromagnetic radiation from exiting, except where the little holes are, but it stops most of it so that it's EMI compliant and it doesn't interrupt other devices in the area, like a radio giving off little frequencies in the air of magnetism traveling through the air as energy. Okay, so this thing got bolted on by these 4 little bolts. This black gear with the shaft coming off it came off of right here, which is part of this gear shaft assembly. It came out of that hole. You can see right through it to the far wall. Right in the center there. Upper right. This gear with no shaft coming out of it came out of right it was like right back here somewhere, but it was part of this cover right here, and you can actually see this black thing I'm touching right here was connected to that gear somehow. So that's all in the instruction manual. I'll have to review that to get that one back in. These 5 were actually bolting down the gear assembly. I couldn't find the other 2, but it actually ended up in my favor because I didn't remove this front gear assembly. I didn't need to. So I'm glad I kept it where it is. That actually played to my advantage big time. So I can just bolt those 5 in right now because I don't need to remove this gear assembly to do the repair work or the diagnostic work. Because we're only interested in this part that these little yellow wires are plugging into. This whole box, this whole square case, you see it, a cube-shaped case, is the solenoid. And that's the part that we believe failed here. We believe it's not working. And I'll have to make a replacement solenoid or try to fix that solenoid, but I think it'll be hard to get this thing out, and it's bolted in, it's big. I think I can try to make something that will pull that little silver thing in the center of the screen. It's dead center. You see the highlight of it. That's the little arm that is a stopper lever, and it needs to pull toward the camera. And I've shown you how that works. Yeah, now you can see it really well. It's got more light hitting it. That little thing, dead center of the screen right now, right there, that little metal thing is the stopper. There it is. You can see it from another angle. Now, in order to access all of that, you can see that this plastic panel right here, I just broke it. You can see some of the cut marks of where I just snapped it off with an electronic side cutter. I just snapped it right off. All the way up. All the way up. It was like it was covering from right here all the way down, covering all of this. I got pieces of it on the floor here. That's a piece. Here's a piece. No, that's not a piece. Oh, I broke something here. What the heck is this? The final parts, this is a little frame piece that went right... Okay, so here's the frame that's all loose right now. That's loose, and that's loose. This frame piece went like right here. Right like that. It bolts here and here. So I can put that on. All these little screws next to it went to the frame pieces. So one went like right here. One went right here. One went right here into that. One went right here. One went right here. You can see that's the lineup. One went right... actually, I think... Yeah, the little one went right here. This big one was, again, one of the bigger bolts that go to the overall gear assembly. Those are all the big bolts. And I have 5 of those here. So we can put all those in, all the frame ones back in anytime. Now, in order to get this front box off, which is the PCB for the scanner brains, it's the intelligence of the scanning system, we had to unplug this blue plug, which came off the bottom of this board. And you can see the connector for it right there, that black connector. It just snaps up into there. Now we also had to unplug this ribbon cable and this little twisted connector that's hanging in the middle of the screen. And we had to connect that little ribbon cable and that little ribbon cable. You can see it there. And I think that's it, actually. And one ribbon cable goes into there on this board. It goes into there, and that's this one. It's in the upper left. And then one snaps into that little guy right there. And that's this rainbow colored one right here. And then one snaps into there, and that's one of these two, either this one or this one. Actually no, this one with the aluminum foil on it goes into this gray slot right here, and then this one right here above it goes into the far right slot right there. So that's the difference. And so that's where all those go. Now I was trying to unplug these two and I couldn't get them out. I could not get them out, and I didn't want to force it. Maybe there's some tab you have to release. I'm not sure. I'm not that experienced with removing connectors. So that was kind of scary when I couldn't get them out. I wasn't willing to start to try to force it or anything. So I managed to get that out. Just by removing this bottom one and several of the top ones. I was able to just swing it over. It's still plugged in by these couple cables, but they had enough slack for me to just set it off to the side, so it's still connected, kind of. And that gave us access to see all of this. And this board is critical because it's got our 2 connectors that we need to be able to do tests on. Okay, so let me get into that testing aspect with you guys. Well, first of all, as part of the removal of the gear assembly steps, they wanted us to remove what they called the clutch motor, and that's this. And the clutch motor connects onto this shaft right here in the center of the screen, and that's a D-shaped shaft, so it's got a flat face on it, which you can see here. And there's a flat face right here. And that they slide together. You got to line them up just right. Okay? Now, this has got 2 green wires leading into it. You can see the 2 green wires leading into it. And this is called a clutch. When these 2 green wires have 24 volts applied across them, a little coil of wires, a helix-shaped coil, which is also an inductor, gets activated, creating a magnetic field. When that magnetic field happens, it couples the turning of this gear to the turning of the center shaft. By default, this spins. This gear will spin, but notice that the center shaft does not spin. Well, it's spinning a little bit, but it's not really supposed to spin. If I put my finger on it, I can stop it from spinning. See? There we go. It spins a little, but see, it's not spinning. But when you apply a magnetic field to these green wires, they will be coupled and they will spin as one, like that. This is not, the magnetic field is not on there right now, but you can see they're spinning as one. And so that's why it's a clutch. It will couple these 2 shafts turning together. When right now it just happens to do that when there's a little bit too much friction, but they turn freely separately. So they're decoupled when there's no magnetic field applied across these wires. So in order to test this part, we well, wait, before I even, okay, to test it, there's a couple things we can do. First, we can unplug this connector, and we can put a 24 volt voltage across the 2 wires, and then we can try turning this and see if that turns. And if they both turn, then we know it's working. I think it will work. I don't think this is the part that failed. This is important because it connects here, and these big gears are turning off a big motor located somewhere behind, I think behind these big gears or something. But all these big gears are turning, and this taps into the power of that. And that then enables us to turn this shaft. And this shaft turns these little gears back in here. And I'll turn it by hand. Oh, I can't turn it by hand that well, but yeah, I can turn it a little bit. You can see them turning a little bit. Yeah, you can see them turning a little bit. But they're not able to turn freely because of this little metal thing that we talked about. This little lever right here. That little lever. And that lever is a stopper. And that lever is controlled by this solenoid right here. This solenoid has 2 little yellow wires leading to it. And when it has 24 volts applied across these yellow wires, 24 volts and ground, its magnetic field activates, and it has an inductor inside it. And that causes it to become magnetized and pull a little plunger or armature, which then pulls this thing back. And you can see it's easy to pull this thing back. See, I just pulled it back. It moves pretty easily. So this bad boy needs to pull that back, and I think it's not doing that. I think that this is not working anymore. We'll be able to test that theory, though, by attaching to these yellow wires. We can follow them back to the main brains board, and they're here. We can unplug that and attach 24 volts across it, and then see if that lever moves. If that lever moves, then we know the solenoid's working. If it doesn't move, we know something's wrong, and we have to replace the solenoid or repair the solenoid. I like to try to repair it, but it's hard to get out of here. It's bolted in right there, and I don't know, it looks like it'd be hard to get out. Maybe it's not that hard to get out. It's this little connection of wires is going to be in the way, though. This huge rack of wires is all connected to it. So we'd have to unhook that, take those wires off, and somehow slide all this out without having to remove this, which is kind of blocking it. So I don't know if we can actually finesse it out of there. I guess it's possible we could, but It looks tough to get it out of there. So I was just thinking we could just create our own little solenoid and mount it to the bottom of this one and have it just have a string tie off to this little lever and just pull it out toward us. Just pull it. Just create a simple little motor or solenoid. And yeah, that's the way I came up with. Just create a solenoid and mount it to that solenoid, because this solenoid's pretty huge and it's got a bunch of crap connected to it. I don't know if it'd be easy to get it out of there or not. Seems like it'd be really hard. Okay, so those are the two parts. This solenoid right here or this clutch are to blame. This clutch is a magnetic clutch whose job is to make this turn, and this shaft turns the pickup roller, provided that the solenoid remove that little lever, which is a catch, and the gears are able to turn freely then. So they both have to work together. This has to couple these big gears to this shaft to turn it, and the solenoid has to take off the brakes, and then it will turn. So it needs both of these parts working. So I believe one of them has failed, and we have to test both to see which one has failed. And then we have to fix the one that failed, or replace it, or make one. I'd like to not buy anything. I'd like to make or fix parts. I don't want to buy parts. Even though they're only like $8, I think we could learn way more by fixing parts rather than buying replacement parts. I want to learn a lot. And keep things completely free, basically. What else? Oh, to get this solenoid out of here where I have it set for now, not solenoid, magnetic clutch, its little green wires you can see come right off here. They were routed underneath this clip, so I had to lift this clip. In order to do that, I had to press down, or no, I had to press this little tab in, and then it popped out. And then I was able to slide the wire out of it. So that's a cool little connector. It's a wire harness connector, and it's riveted into this piece of plastic, and it holds all these wires neatly and runs them this way. You can see another clip thing kind of is guiding them around this bend. So they put a lot of effort in engineering just into keeping all these wires neatly routed. It's amazing. And then they go through another little channel right here, a little U-shaped channel, and then they curve up. And then they come up and through another U-shaped thing, and then they come up to the solenoid, and then they keep traveling, and they split here two different directions, go right and left. It's just incredible the amount of thought and careful effort that goes into everything with wire routing. You can see here a huge amount of effort, all these little U's and clamps and stuff, and you can even see a zip tie right here. You can see it. It's kind of blurry. There it is. Really nice. And you can see all these wires are twisted. They're not running parallel. They're all twisted up because having the black ground wires twisted with signal wires, that helps to prevent stray electromagnetism from corrupting the signal wires. So the magnetic field created by the ground and the signal wires kind of all protect one another when they're twisted together this way. So that's why they use twisting, and I think that's really cool. Notice that these do not use twisting, so we have to assume that these are just power wires. They're not concerned about signal integrity, and so that's why they don't bother twisting it. And in fact, you can see that they all come to right here, and I'm guessing that thing says PWB. Looks like it might be a motor. So I think those are just motor power lines, but I'm not really sure. I don't know every little thing. I know a lot though. Well, that's interesting. You can see that here they just have a bunch of wires enter into shrink tubing just loosely attached, and then that they just go to this this motor, and they plug in right there. So just that little wire run from point A to point B, they just put some loose shrink tubing on it just to protect them a little bit. That's crazy, the amount of detail, attention to detail, just protecting every little thing. Just everything's thought of. They're just so careful. This is such a quality product. So yeah, anyways, we didn't have to take this gear assembly off to be able to find and work with and see how things work, because we just busted off some plastic to access. I was able to see through a little crack right here and kind of see what's going on. So I was like, shoot, if I just snap away some plastic that doesn't seem to be really necessary per se, then we'll be golden. So I just said, YOLO, I'm doing it, man. And I'm glad I did, because that saved us from a lot of headaches. Big time. We didn't have to remove this. We didn't have to remove this whole scanner assembly up here. None of that. I just got sick of removing all these parts. They wanted me to remove everything, man. They wanted me to remove this frame, all kinds of stuff. I just had it. I'm not going to remove a million things. Look at all this stuff I had to remove. All of these things. Oh, I mean, I got a bunch of other junk in my bed too, but it's just crazy. So I saved myself there quite a bit of work. So yeah, you can see exactly where I'm at now, as far as all the parts scattered and my logic about it all, and my plans and how I intend to fix the components, or test the components and fix the components. So that's what's going on. We know how it works. We know what went wrong. We narrowed down all kinds of information. So now I'm going to start putting things back a little bit. Just some of the basic stuff I want to put back, because it's chaos. And I will lose things if I don't watch it. Hi, BB beams. I just want to reduce complexity of all the stuff we've removed that doesn't need to be removed. So I'm just going to try to put back as much as I can reasonably put back right now. In the same order I took it off, by the way. That's important. I'm going to go in reverse order. And I took notes of the ordering of every single thing I did. And I'll show you guys that. Those notes. So I wrote steps I actually took. Stop listening. And you can see right cover, that's the first thing I took off. Right upper cover I took off second. Right rear cover third. Input output cover fourth. Left rear cover fifth. Back cover sixth. Left cover seventh. Top cover assembly with some notes, which required also removing several steps I actually took of a cure, along with a rack of teeth. Okay, my text-to-speech just butchered that. I know I didn't say that, so I'm kind of confused there, but alright. So I just corrected that. And then I took off the frontmost PCB with its 4 screws. And then I removed the gear that was black from the upper rightmost portion of the gear assembly area. And then I removed the bottom left little motor called a mini clutch assembly by removing an E-clip. And then I removed several screws connecting the frame housing.
And I'm putting those back now. And then I remove several screws connecting the gear assembly to the right side. So I can put the gear assembly screws. So basically I can reverse these two steps completely without messing up anything. But I can't reverse all these steps because we have to do work before we put everything away. But this will at least get like 9 screws back into the machine, and we'll have less screws kind of just hanging out, tempting fate to get lost. Murphy's Law and all that. I don't want to have too many screws hanging out. I guess I could just rely on memory and not have the notes, but my concern would be that I could oh my gosh, hold on. Grr. My concern would be that I would maybe have this stuff apart for days and forget what I did. And I don't want to have to watch the video to try to reverse engineer everything. And I don't know how loyally I captured every little screw being removed on video. I mean, I assume most of it was captured well, but there's a chance that some things might have been missed in the video footage. Okay. Uh-huh. 1, 2, 3, 4. Yeah, we're good. There's just that one screw that I had to take this frame off of to access to screw it in. Okay. Now you. And now you. I was just taking screws off pretty randomly at this point, just desperate to try to get anything that might have been in the way out of the way of the gear assembly, which I thought I had to remove. And thank goodness I didn't have to remove it by just breaking a bunch of plastic stuff that I didn't think was mission critical. I mean, I'm sure I did weaken some stuff by doing it, but I'll take a slightly weaker frame in certain areas than a broken printer that requires me to do an insane amount of disassembly, and the more parts I disassemble, the further I get from I don't know, I feel like if you take the printer apart too much, you might somehow lose your way at putting it back together and have, I don't know. It's just like the more taken apart this thing got, the more I started to doubt I'll be able to put it back together again, if that makes sense. It just gets more and more overwhelming as the parts start to cover my entire room that they're coming off this thing. And I would think that would be something others can relate to if they've ever taken apart anything complicated. It's kind of a fear you'll have, because you're like, I won't be able to remember everything I did, and even if I take notes, this is starting to get to be too much for anyone to remember all these steps that I'm taking. That's why I'm putting stuff back now. Normally you'd wait till the end to start putting screws back, but I'm doing it now because I just want to kind of cut back on the complexity of getting things back together later. I'm terrified right now. There's too many parts hanging out for comfort in my mind. Yes, I found the last spot I took a screw out. It was really hidden. Okay. Okay. That's a heck of a lot less screws hanging out. Now I can start putting some of my tools away. Who would have thought that this little mirror for dentists would be really useful for electronics repair? There are areas you just cannot see, and this thing is a little hack. You can reach it in and get to see around corners. It's insane. Like, I can see this really good for car repair too. You just need to be able to see what's going on around corners that are blind. Who knows, maybe even like those little scopes that they send into bodies for orthoscopic surgery. A little orthoscopic scope might be nice to be able to transverse on a camera, looking into things without even taking it apart. You can diagnose. I could have avoided taking apart most of this stuff if I had a scope like that to weasel my way in like a little snake and get to see how everything works and see how the gears are moving and stuff while it's running. I wouldn't even have to take anything apart. That'd be just incredible. I'm not taking apart more. I'm putting it back together a little bit. Not entirely, but a little bit. I'm not going to be able to finish a whole lot more today. So I'm going to end up just sliding everything. I'm going to put this thing back on. This little this stupid little door is so complicated. Oof. Crazy little door.